Okay, so let's have we're going to do a quick little conversation about sampling and what sampling is and why we do it. We are not, however, going to spend a ton on this. There are going to be a few times this quarter I'm going to ask you to do a little bit of sampling, but there'll be some pretty clear instructions around that. Sampling is a big deal, though. There are whole courses on designing studies. How do you get the information you want? I'm going to do a little experiment with you guys in a separate assignment I'll post today or tomorrow. That'll show some of the difficulties in getting good data in some contexts. And one of the most important things we can do to get good data is get a good sample. Sample, remember, is a portion of the population you study because you can't study the whole population, right? A census, that's if you were able to study the entire population, is usually impossible or often impossible and very difficult to accomplish. So we usually try to get a sample. But how do you choose that sample, right? One of the key features when you choose a sample is that you want your sample to be a representative sample. So let's put this down, representative sample. This is the goal. So a representative sample, is kind of what it sounds like, something that's going to represent the population well. In other words, it should have the same relevant characteristics as the population. Right? It doesn't favor, and it doesn't favor any, let's put this down, it does not favor any particular subgroup from the population. Okay. So what do we mean by this? Well, let me try giving you a bad example. I've posted a link. I'll share it here, although it's too long to probably read at this moment, but you can at least take a look. But there it is linked in the notes, so you'll be able to see it there. But here's a nice case study from the 1936 presidential election. Again, I'll let you read through this. But if you read through it, what happened in this election, a reputable polling institution, right, who had done pretty accurate polling for years before this event, was making a prediction about the election. And the piece I linked to goes into a lot more detail, but let's just say it this way. Their prediction this year was horrifyingly wrong. They predicted the wrong winner, and they predicted the winner to win by a large margin. And instead, this person lost by a large margin. So they were very, very, very off in their prediction. And one of the problems, among many, but one of the big problems was that a large part of the way they went through creating their sample was through phone directories. Right? They used the telephone book to get names to, and then they sent letters out to these people asking who they would vote for. Well, at that point in history, in 1936, having a phone in your house was still a bit of a luxury. It certainly wasn't as widely available as it is now. And so that sample tended to overrepresent the upper and middle class folks in the population. Right, and so those, and as we all know, which often seems to be the case, people in certain economic blocks often vote in similar directions, among other demographics. And so you had this skewed data, right? Their sample was not representing the population well. So that's one of the things we want to avoid. So I'm going to quickly go through a couple of ways in which we can create samples. Excuse me for 1 second. Sorry, I hit something wrong and everything was going crazy on my end for a moment. So let's go through a couple of ways in which we can create samples and try to get samples that are representative. So what we want is a random sample, right? And this is sampling in which every member of the population has an equal chance of being selected, or equal chance to be selected for the sample, right? So that anybody has the same chance to be selected, at least when you begin. So the simplest form of this is what we call a simple random sample. I'll just describe this as names in a hat, right? Essentially what I mean is this: if I wanted to take a sample from your class, if I put all of your names on a hat, in a hat, and picked one, or picked 5 of you to be my sample, every name in that hat has the same chance of being selected, okay? So that's all we mean by simple random sample. Or throwing a dart at a board where each portion represents somebody in your population. Okay, this is not the only way to do random samples. For instance, I could also, if I was meeting in an in-class, if I was meeting in class where people are sitting in rows of desks, I could decide to pick one of the rows at random, right? So if there are 4 rows in the classroom, everybody has a 1/4 chance of being picked. You all have the same chance to be selected before the class starts. It's not the same as putting names in a hat, right? The difference is with the simple random sample, let me add to this, every possible grouping has the same chance of being chosen, right? So if I put everyone's names in a hat, I could get any possible group of 5 of you in the class. If I choose a row at random, everybody still has the same chance of being selected. If there were 4 rows, it'd be 1 out of 4, but I couldn't get some groupings, right? You could never get a group with people from different rows. So it's not exactly the same thing, okay? Let's see, we have a few more kinds of sampling. We have stratified sampling, right? And in this, you the population is divided into subgroups. And then a proportionate random sample, random sample is chosen in each subgroup that we sometimes call stratum. Okay, so for example, if I wanted to do, if I wanted to understand something about students at South Seattle College, one thing I might do is divide them up by major, right? Those could be your strata. People that have, undecided, people that are in a STEM major, people that are in an English major, health major, whatever majors people are in, those are the groups. And then we pick a proportionate sample. So for instance, if 25% of our students are in STEM fields, I would pick 25% of my total sample from those strata. Another place we see this a lot, let's say you're doing a medical study, you might want to get, if there's a procedure that's done on the entire population, you might want to divide up by age. And so you want to make sure you get a proportionate number of 0 to 10-year-olds, 10 to 20, 20 to 30, and so on, or whatever strata makes sense to you. So sometimes dividing it up by strata so you get a proportional sample is a way that people do these things. Let's talk about cluster sample. We divide the population into clusters and choose a sample of clusters. So an example of this might be if the city of Seattle wanted to, I don't know, if they were interested in, they wanted to do some research on people who live in Seattle, right? So maybe they wanted to know about people's driving habits in Seattle. So they can't ask everybody, and they want to send people door to door. A way to cluster people might be by block. So each block is a cluster of citizens. And then you pick entire blocks and go to them. You might go to 50 different blocks in Seattle spread across the city, picked randomly, so that your canvassers or people that are walking around asking questions don't have to move very far. They're on a block and they just go to that block, right? So you've made this little cluster and then you choose from among your clusters. Another one is a systematic sample. This would be something like choosing every nth member of the population, right? Every 10th member, every 50th, every 100th. This might be something like quality control in a factory. If you have a factory that's producing some kind of electronics, let's say, and they're pumping out a few thousand per day, if you're in charge of quality control, you might pull every 200th electronic off the line and test it, right? Probably not cost effective to test all of them, so you do some random sampling to see how, to get an idea of the quality of these things, right? And so this is a good place to use the systematic sample. It's easy to just, every 200th gets pulled off, and you should have a good sample of all of your products. And then one more, probably typically the worst kind of sampling would be convenience sampling. Right, and this is, the sample is convenient to the researcher, right? So here's a silly example. If I wanted to understand something about how people are coping with moving their lives online. Let's say I want to do a study on that. Well, since I have you guys in my class already in the habit of communicating with me, it would be really easy for me to send a survey to you guys, and I could get, right, I have, I don't know, 90 students this quarter. So all of a sudden I could have a sample of 90 very easily. I already have all your emails. It's a super convenient sample for me. It's probably not a very good representation of the country as a whole or the world as a whole right now, right? Being a student is a very particular position to be in, right? And so it wouldn't be a very good representation of all. And so convenience samples are typically not very good science, right? They're usually done because of limitations of money or time for these kinds of things, right? So I might do that study just as a casual study of curiosity for myself, but it wouldn't have very good relevance to the scientific community. Okay, that is actually all I'm going to say about sampling. Like I said, you guys are not going to have to do much with sampling, and there's only a couple places where we're going to have to be careful of it, and I'll make sure to call those out when we hit them. For the most part, we are going to be taking data that other people have collected, and we are going to assume that it's good data, right? That they did their due diligence to make sure they got good samples, didn't make errors in recording it, those kinds of things that can happen when you're doing a study. I do want us to encourage us to to start to develop a critical eye when we read scientific articles and papers online. I know in particular in this current climate, there is no shortage of people sending things they find online out. And as you develop a good eye for these things and a good critical mind, you'll see that a lot of them don't really say much of anything or don't have much significance. One of the things sometimes is looking at samples. How are people getting the samples to make their claims? But we won't spend a ton of that this quarter, so I'm not going to go into more detail now. Okay, that is it for now.